In the previous problem, we tried to figure out, or actually find out, we tried to figure out the domain of the function f of x is equal to 1 over, I should say 1 divided by, x squared minus 4. And that may have been a little tricky for you because sometimes we forget that when it comes to squares, we usually have two answers. Remember that the denominator cannot be 0. And there are actually two values for x that would make the denominator 0. We figured out that -2 is not allowed because if you take -2,
It's night too, boss.
if you take -2 and square it, you get 4. And 4 minus 4 would give you a 0 in the denominator. We also figured out that x cannot be +2 for the same reason, right? Because 2 squared is 4. And then 4 minus 4 would also give you 0. I wanted to do this video to show you what the graph of the function looks like. And the graph of the function looks like this. It's a very interesting function. And as you can see, this function would not be a polynomial because it has breaks in the graph. But what I want you to notice is that when x is equal to -2, the graph does not touch the curve. It looks like it does because we're not zoomed in all the way, but technically this graph gets closer and closer to that vertical asymptote, but never touches. And in a moment, I'll zoom in to prove that. If you look at x is equal to +2, we have the same thing. We have a vertical asymptote there when x is 2. And that graph, again, will never touch those vertical lines. So the two asymptotes are never violated by the graph. Let's zoom in and take a look just to prove a point. Let me delete my drawing there. But as I zoom in closer and closer, notice that the graph does not touch that line. It gets closer and closer. And in case you've lost it, let me just trace it here. This is the line here where x is 2. And again, notice I can continue to zoom and zoom. It will never touch that vertical asymptote. And let me zoom back out. Let's take a look at another problem. Let me change the denominator to x squared minus 9. Well, notice this time I have two values, again, that are not allowed for the domain. And what would those be? Well, let's think about that. If our function is f of x is equal to 1 divided by x squared minus 9, what two values of x are not allowed? In other words, what number squared would give you 9, which would make you have 9 minus 9, which is 0? Well, we know that -3 times itself is 9, so -3 is not allowed because -3 squared is 9. And then, of course, 9 minus 9 would give you a 0 in the denominator. And also, we cannot use +3 because +3 squared would give you a 9, and then 9 minus 9 would be 0 again. And if you take a look at the graph, we have the same scenario as before. If you look here where x is equal to +3, we have a vertical asymptote. And if I zoomed in again, you would notice that the graph never touches that line x is equal to +3, nor does the graph touch the line x is equal to -3. I'm not going to zoom in this time because I showed that to you in the last slide. And let's do one more. Let's change it to y is equal to 1 divided by x squared. Well, here, if we have 1 divided by x squared for the function, Here we only have one value that's not allowed, and that value is 0. There's only one value of x that can make that denominator 0, and that is 0, because 0 squared is 0. And if you look at the line x is equal to 0 right here, it's also known as the y-axis, that would be your vertical asymptote. So how would we write the domain? Well, we could just write out all real numbers except 0. Or I could say, well, it's anything from negative infinity all the way up to 0, not including 0, and then everything on the other side of 0 all the way to positive infinity. So that's another way we can write the domain. Now earlier, we had the function f of x is equal to, I think it was 1 divided by x squared minus 9. And we said that -2 and +2 are not allowed in the domain. So we could write it this way. The domain would be every x value that you want from negative infinity all the way to -2. And then if you want to, you can also choose any real number between -2 and +2. But you can't use 2 because that would give you a 0 in the denominator. And then you can pick any real number that's larger than 2, so from 2 to infinity. So we could have written it that way. What if we go back to the problem where we have, let's see, we had f of x is equal to 1 over x squared minus, I think it was 9. That's the one I meant to do, and for some reason I did the 4. So let's do x squared minus 9 in the denominator. And remember, we said that x could not be -3 and x could not be +3. So we could say all real numbers except for -3 and +3. Or we could write it this way. The domain is from negative infinity all the way up to -3. Or anything between -3 and +3 would be allowed. And finally, we could pick anything from +3, not including +3, but anything larger than 3 to infinity. So we could have written the domain that way. So get used to looking at the domain written using this notation, or you could just say all real numbers except, -2 and 2, or -3 and 3, whichever the case may be. Thank you.